This video provides easy-to-follow instructions for you to create and animate this butterfly valve using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 8 segments. In segment 1, you will establish the design intent and preview the top-down modeling process using Onshape. In segment 2, you will create the valve body. In segment 3, you will create the valve stem. In segment 4, you will create the retainer plate. In segment 5, you will create the actuator arm. In segment 6, you will create the valve plate. In segment 7, you will assemble and animate your device. In segment 8, you will make some changes to the device to see if it will update correctly. Now you are ready to begin the project. Before we model the part in Onshape, we have to establish our design intent. We want our model to be flexible to possible design changes. We have to establish the relationship between parts so the model will update predictively. In this butterfly valve, there are 2 parameters that we may want to change during the design process. First, the inside diameter of the valve may be increased. Next, the height of the body may need to be revised larger or smaller. So how do we want the model to respond to these changes? When the inside diameter of the body is changed, we want the outside diameter to also increase. We want the wall thickness to remain unchanged. We want the associated parts, like the stem and valve plate, to also change and maintain their functionality. When the height of the valve body is adjusted to be taller or shorter, the valve mechanism should remain at the center of the body. To establish and maintain the relationships between multiple parts, we will use a top-down design method. Using a top-down modeling method helps establish our design intent by modeling the 5 individual parts together in the same part studio and sharing the associated parameters between related parts. In the Onshape document, the inside diameter and the height can be set as variables. We can then use these parameters to drive changes in multiple parts to enforce our design intent. In this segment, we will model the valve body using Onshape. Let's start by previewing the features we will use to create this parametric model. First, we will choose the top view for our base sketch and place sketch 1 on the top sketch plane. The center of sketch 1 will be coincident to the origin on the sketch plane. With extrude 1, we will create the cylinder. In sketch 2, we will define the size of the bosses and holes. With extrude 2, we will create the rear boss. In extrude 3, we will create the front boss. With extrude 4, we will create the shaft hole. In extrude 5, we will create the counter bore for the shaft hole. Extrude 6 creates the vertical hole through the center. Sketch 3 defines the size and location of one mounting tab. Extrude 7 creates the mounting tab. Circular pattern 1 adds evenly spaced tabs on the top. Mirror 1 adds the tabs to the bottom edge. Hole 1 adds one instance of the screw holes to the boss. Lastly, circular pattern 2 adds the remaining screw holes to the boss. Now let's get started creating this part using Onshape. I've started a new Onshape document and named it valve body. Before starting the sketch, I want to check my workspace units. Make sure the length is set to millimeters and the mass is set to kilograms. As stated in the design intent, we have identified 2 parameters that we may need to change during the design process. We will start by creating variables for these parameters. Click on the button on the right to open the variable table for the document. The first variable is the inside diameter. Use ID as its name. This is a length. It has an initial value of 200 millimeters. The other is the vertical height. Use height as its name. It is also a length. It has an initial value of 250 millimeters. Click the button to close the table. Notice that these variables have been added to the top of the feature list. Now I'll start a new sketch in this part studio. Click on the top sketch plane. Use N on the keyboard to view normal and P to turn off the visibility of the sketch planes. We will use the sketch to establish some basic features of the part, including the inside diameter, the wall thickness, and the distance of the bosses to the outside of the cylinder. From the toolbar, choose Center Point Circle. Click coincident to the origin to start the circle, drag and click. Click coincident to the origin again and create another larger circle. These circles represent the outside of the cylinder and the center hole. We will start by setting the wall thickness. Click on the Dimension tool and click on both circles. Set the distance to 25 millimeters. Now we can set the inside diameter. Click on the inner circle. Use hashtag to open the variables and choose ID from the list. Use Enter to display the value. It should be 200 millimeters. We will now use construction lines to set the distance from the outside of the cylinder to the faces of the front and rear bosses. Click on Line and then Construction. Hover the mouse at the origin and move down to the outside of the circle. Look for a vertical and coincident icons and click to start the line. Extend the line down vertical and double-click to end. Set the length at 25 millimeters. The end point of this line is the location of the face of the front boss. Use the same process to create a lineup on the top for the face of the rear boss. From the Constraint menu, click on Equal to set both lines equal. This looks correct. Use the green check to close. Right-click and view Isometric. We can now use Sketch 1 to create the base cylinder. From the Feature toolbar, click on the Extrude tool. This will be new. Click on both regions of the inner and outer circles to form a solid cylinder. We will remove material from the center later, after creating the bosses. The end type will be blind. Click on Symmetric to extrude in both direction from the sketch plane and leave the origin at the center. Set the depth using a hashtag and choosing height from the variable list. Use Enter to display 250 millimeters. This looks correct. Click the green check to accept and create the base part. To sketch the circles for the bosses, we will need a new sketch plane. First, click on Part 1 in the Parts list and turn off its visibility. Next, in the Feature list, click on Sketch 1 and turn on its visibility. Now click on the Plane tool on the toolbar. This will be a plane point. Click on the end point of the construction line in the front. This will be the point to place the plane. Use P on the keyboard to turn on the visibility of the planes. Click on the front plane and a new parallel plane is created at the point. This looks right. Use the green check to close. Notice Plane 1 has been added to the feature list. Referring back to the drawing, there are 3 elements that define the features on the bosses. A 60 mm center hole, a 100 mm countersink and back boss, and a 175 mm front boss. In the parts list, click the part and turn its visibility back on. Start a new sketch and click on Plane 1 for the sketch plane. Use N on the keyboard to view normal. Using the origin for the center, use the center point circle to construct the elements. A 60 mm diameter circle, a 100 mm diameter circle, a 175 mm diameter circle. That looks good. Use the green check to end the sketch. Right-click and choose Isometric View. The first feature we will add here is the rear boss. Click on the Extrude tool on the toolbar. Use Add. For the sketch region, click on both of the center circles. For the direction, toward the rear of the cylinder. For the end type, choose up to vertex. Click on Sketch 1 on the feature list to turn on its visibility. Click on the endpoint of the rear construction line to use it as the vertex. This looks correct. Use the green check to close. We can now remove material for the shaft hole. Click on Extrude again. Use Remove. Click on Sketch 2 to turn on its visibility. For the region, click on the center hole. Direction is toward the rear. End type is up to face. Click on the face of the rear boss. We don't want the hole to go all the way through, so we will use an offset for the hole to stop. Looking back at the drawing, the hole ends leaving 15 mm of material at the rear boss. Enter 15 mm for the offset. Use the green check to close. To check on the depth of the hole, we can use a section view. Click on the camera and render options and choose section view from the menu. Click on the right plane to use as the cutting plane. Use the green check to close. The hole should be visible. Click on the measure tool in the lower right. Click on the face of the rear boss. Click on the end face of the hole. The measurement should be 15 millimeters. This looks right. Right-click and turn off section view. We can now add the front boss. Click on Extrude. Use Add. Click on Sketch 2 and turn on its visibility. For the region, click on the outer region of the sketch. The direction is toward the cylinder. The end type is up to Next. The boss should extend to meet the cylinder. This look good. Use the green check. The last step for the boss is adding the counter bore hole. Click on Extrude. Use Remove. Click on Sketch 2 again to view. Click on the center region for the counter bore. The depth is 25 millimeters. This looks correct. Use the green check. With the bosses done, we can now remove material to form the center hole. Click on the Extrude tool. Use Remove. Click on Sketch 1 to make it visible. If needed, turn off Part 1 in the parts list to view the sketch. Click on the center region of the sketch. The end type is through all. Click the box for symmetric to both directions. Turn back on the visibility of Part 1 to view the result. Click on the Merge scope and click on Part 1 in the parts list. This looks correct. Use the green check to close. Next, we will use a sketch to define one of the mounting tabs on the top outside edge. Referring to the drawings, the center of the mounting hole is 60 millimeters from the inside edge of the cylinder. The semicircular end of the tab has a radius of 30 millimeters or a diameter of 60 millimeters. The bolt hole is concentric to the semicircular end with a diameter of 25 millimeters. Start a new sketch and click on the top face of the cylinder for the sketch plane. Use N on the keyboard to view normal. Click on Line and Construction. Hover at the origin and move up to the inner edge of the cylinder. When you see the vertical and coincident icons, click to start and stretch a vertical line. Double-click to end. Enter 60 millimeters for the length. Click on the slot tool on the toolbar. Click on the construction line. Double-click on the diameter and enter 60 millimeters. Click the left mouse button to end the slot. For the bolt hole, click on the center point circle tool. Click coincident to the end of the construction line. Enter 25 millimeters for the diameter. This looks correct. Use the green check to close. We can now extrude the sketch to create the tab. Click on the Extrude tool on the toolbar. This will add to the existing part. Click on the portion of the sketch for the tab. This should extrude down toward the body. The depth is 15 millimeters. This looks good. Use the green check to close. Next, we can create the two additional incidences of the tabs on the top edge. Click on the Circular Pattern tool on the toolbar. Choose Feature Pattern from the drop-down menu. For the feature to pattern, click on the Extrude for the tab. For the axis of the pattern, click on the center hole of the part. For the instance count, enter 3. Check the box to reapply features. This looks right. Use the green check to close. The same pattern of tabs are also on the bottom of the part. We can mirror the set to create them again on the bottom. Click on the Mirror tool on the toolbar. This will be a feature mirror. For the features to mirror, choose the Extrude for the tab and the Circular Pattern from the feature list. To choose the mirror plane, use P on the keyboard to turn on the visibility of the planes. Click on the top plane. Check the box to reapply features. This looks like what I wanted. Use the green check to close. Next, we have the 3 threaded holes on the face of the front boss. The centers of the holes are located on a centerline circle with a diameter of 137.5 millimeters. This makes the distance from the center of the boss to the hole center 68.75 millimeters. To locate the hole, we could use a sketch or a mate connector. Let's use a mate connector. I need to use the tool to add a mate connector, but I don't know where it is on the toolbar. Click on the Search toolbox and enter Mate. I can click it here on the list. I want to choose a mate connector on the front of the boss. Click on Front on the View cube to view this face. I only see one mate connector at the center. I will choose this one and then check Move in the dialog box. I want to move the location vertical in the Y direction, 68.75 millimeters. This looks correct. Use the green check to close. Notice this mate connector has been added to the feature list. Now we can add one instance of the hole feature on the boss. From the drawing, we can see it is a metric threaded hole for M12 bolt with a 1.75 thread pitch. Click on the hole feature tool on the toolbar. This is metric. This is simple. It is tapped. It is M12. It has a pitch of 1.75 millimeters. The drill diameter is 10.3 millimeters. The hole is drilled to a depth of 35 millimeters. I have set the drill size to 10.3 millimeters. The depth to 35 millimeters. Last, the hole is threaded to a depth of 29.75. And that is set here. For the hole option, click on the button for the mate connector in the dialog box. Click on the mate connector on the boss. That looks good. Use the green check to close. We need 2 more screw holes for the set. We can use a circular pattern feature to add them. Click on circular pattern on the toolbar. From the drop-down, choose feature pattern. For the feature, click on the hole. For the axis of the pattern, click on the center hole. For the instance count, enter 3. This looks right. Use the green check to close. With this, our valve body is complete. In this segment, we will create the valve stem. We will start by examining the drawings and identifying the features that share the same specifications with the body. The central shaft of the part has a diameter of 60 millimeters. This matches the shaft hole at the center of the body. There is a 50 millimeters end for mounting the actuator arm. There is a 100 millimeters diameter shoulder for holding the stem in the body. It has a width of 25 millimeters and matches the recess on the body. The total length of the shaft is 332 millimeters. When it is fitted into the body, there is a clearance space of 3 millimeters between the end of the shaft and the end face of the shaft hole in the body. Let's start by creating the shaft and the shoulder. I have opened my Onshape document for this butterfly valve, and I am working in the same part studio with the body. Looking on the feature list, I can see all of the features that make up the body. This list is getting long, and now I will be adding more parts. To keep this list organized and a little shorter, let's add a folder. Click on Sketch 1 in the list, hold down the Shift key, scroll to the bottom of the list, and click on the last feature. In this case, is the pattern for the screw holes. All of the features should now be selected. Right-click and choose Add Selection to Folder. Enter body for the folder name. Use the green check to close. Notice that all of the features are now packed into a folder named Body, and the number indicates the number of features. You can expand the folder to access its contents. If you later want to remove the folder, right-click and choose Unpack Folder. Now we will start the valve stem. Click to start a new sketch. Click on the face of the boss to use it for the sketch plane. Use N on the keyboard to view normal. Click on the Use tool on the sketch toolbar. Click on the shaft hole and the shoulder hole to use these entities in the sketch. Use the green check to end the sketch. Click on Extrude on the toolbar. We will start with the shoulder. Choose the sketch region for the shoulder. This should extend into the body. For the end type, choose Up to Part. Click on the body to choose the part. Make sure this is a new part. This looks right. Use the green check to close. In the parts list, you can turn off the visibility of the body to view the new parts so far. This looks okay. Turn the body back on. Next, we will use a section view when making the shaft feature. Click on the camera and render options and choose section view. For cutting plane, choose the right view from the feature list. Click on Extrude again to make the shaft. Click on the sketch to make it visible again. Click on the region for the shaft. The direction should be into the body. For the end type, choose Up to Face. Click on the face at the end of the shaft hole in the body. We know that the shaft should have a 3 mm clearance, so we will use an offset. Click on the offset distance. Enter 3 mm for the distance. This looks right. Now we need 50 mm of the shaft extending away from the boss face for mounting the actuator. Check the box for a second end position. This will be blind. Enter 50 mm for the distance. Click on the Add feature and make sure it will be added to Part 2. This looks good. Use the green check to close. Right-click and turn off section view. Looking back at the drawing, there is a notch cut from the stem to fit the valve plate. This notch length is the same as the inside diameter of the valve body at 200 millimeters. We can use our variable to set this length. The depth of the notch is halfway through the stem. Also, there are 3 holes centered along the length of the notch. The middle hole is centered in the notch. The outer holes are 40 millimeters from each end. These are tapped holes extending through the shaft. They are threaded for M8 by 1.25 millimeter screws. To create this feature, we will again use a section view. Click on the camera and render options and choose section view. For the cutting plane, choose the top plane from the feature list. Click to start a new sketch from the toolbar. Choose the top sketch plane from the feature list. Use N on the keyboard to view normal. The origin should be visible in the center of the body. If not, click on the origin in the feature list to turn on its visibility. Click on the center point rectangle tool on the toolbar. Click coincident to the origin for the center. Stretch the rectangle to be larger than the stem and click. Click on the dimension tool. Click on the side of the rectangle to set the length. From the keyboard, use the hashtag to open the variable list. Choose hashtag ID from the list. Use Enter and 200 millimeters should be the value. Click on the width and enter 60 millimeters. To mark the locations for the screw holes, we will use points. Click on the point tool on the toolbar. Click on the origin for the center point. Hover the cursor on the origin and drag a projection line down the center and place a point near each end. Click on the dimension tool and set the distance from each point to the end at 40 millimeters. This looks good. Use the green check to close the sketch. Right-click and turn off section view. On the parts list, turn off the visibility of the body. Click on Extrude on the feature toolbar. Click on Remove. For the face or region, click on the sketch on the feature list. The direction is up. The end type is through all. This looks correct. Use the green check to close. Next, we will create the threaded holes. Click on the hole tool on the feature toolbar. These are metric. They are simple. For the hole type, they are tapped. The size is M8. The pitch is 1.25 millimeters. The drill diameter is 6.8 millimeters. They will start from the sketch plane. They are through all. On the feature list, click to make the sketch visible. Click on the sketch points to create the holes. This looks right. Use the green check to close. On the parts list, click on the body to turn on its visibility. Next, let's check the responsiveness of the stem to changing the inside diameter of the body. We will use a section view to observe the change. Click on the camera and render options and choose section view. Click on the top plane in the feature list for the cutting plane. On the right, click on the button to open the variable table. Change the value for the inside diameter from 200 to 250 millimeters. Observe that the stem length, the notch length, and the hole locations all update when this change is made to the body. This is the behavior that we wanted. Reset the value to 200 millimeters. Close the variable table and exit section view. On the parts list, right-click on Part 2 and rename to Stem. The part is now complete. Looking in the feature list, let's make a folder to hold all of the features for the stem. Click on the sketch, hold down the Shift key, and then click on the last feature. All of the features should now be selected. Right-click on the selection and choose Add Selection to Folder. Name the folder Stem. The folder should appear in the feature list. In this segment, we will create the retainer plate for the butterfly valve. Let's look first at the drawings of the part. The plate has an outside diameter of 175 millimeters. The concentric center hole has a diameter of 60 millimeters. The 3 evenly spaced holes are coincident to a center line circle with a diameter of 137.5 millimeters. The holes have a diameter of 14 millimeters. The thickness is 10 millimeters. Next, we want to identify the parameters that are shared with the body and can be used by copying them from the existing part to the new sketch. The outside diameter, the shaft hole diameter, and the centers of the holes can all be used from the body. Click to start a new sketch. Click on the face of the boss to use it for the sketch plane. In the parts list, click on the stem to turn off its visibility. Use N on the keyboard to view normal. From the sketch toolbar, click on the Use tool. Click on the center shaft hole to select it. Click on the outer edge of the boss to select it. We will now create the circles for the bolt clearance holes. Click on the center point circle from the sketch toolbar. Hover the mouse over the existing hole and look for the concentric constraint icon. Click to start the circle, make it a little larger than the existing hole and enter 14 for the diameter. Make 2 more circles concentric to the other holes. From the constraint menu, choose the equal constraint. Click on the dimensioned hole and then one of the other holes to set them equal. Repeat for the other hole. This looks right, use the green check to close. Click on Extrude on the feature toolbar. For the sketch region, click on the sketch in the feature list. This will be a new part. The direction should be away from the body. The end type is blind. The depth is 10 millimeters. This looks right, use the green check to close. I can see that a new part has been added in the parts list. Rename the part to retainer. Change its appearance to a light color that contrasts with the body. Last, let's place the features for this part in a folder on the feature list. Select the features used for the retainer on the feature list. Right-click and choose Add Selection to Folder. Name the folder Retainer. This part is now complete. In this segment, we will create the actuator arm for the butterfly valve. Let's start by examining the drawing. The front view shows the arm is symmetric along its length. It is constructed between 2 circle centers. The distance between centers is 200 millimeters. On the stem end, the 60 millimeters center hole matches the valve stem where it will attach. This end is circular and has an outside diameter of 100 millimeters and a thickness of 40 millimeters. The arm has a semicircular end with a radius of 25 millimeters. Concentric to the end is a hole with a diameter of 20 millimeters. The arm has a thickness of 10 millimeters. To start, on the parts list, click on the eye, turn off the visibility of all of the parts. Now, turn on just the stem visibility. Click on the Sketch button in the toolbar to start a new sketch. Click on the end of the stem to use this face as the sketch plane. Use N on the keyboard to view normal. Click on the Use tool on the sketch toolbar. Click on the end of the stem to use this circle in the sketch. Click on the center point circle on the toolbar. Click on the point concentric to the stem for the center of the circle. Enter 100 for the diameter. Hover on the center of the circle and move the mouse up. Make sure it is showing a vertical constraint icon. Click for the center, enter 20 millimeters for the diameter. Click on the center again and enter 50 millimeters for the diameter. Click on the Dimension tool, set the distance between centers to 200 millimeters. Click on the Line tool on the toolbar. Click coincident to the edge of the top circle and drag down to the edge of the lower circle. Look for the coincident and tangent constraint icons to show and double-click to end the line. Repeat the same construction on the other side. These lines also must be tangent to the top circle. Click on both lines and the top circle to select them. On the Constraint menu, click on the Tangent constraint. I can see all the lines have turned black, showing they are fully constrained. Use the green check to close. On the parts list, click on the retainer plate to turn on its visibility. Click on the Extrude button on the toolbar. This will be a new part. For the sketch, click on the region of the sketch where the arm fits to the stem. The direction should be in towards the retainer plate. For the end type, choose Up to Part. Click on the retainer plate for the part. This looks correct, use the green check to close. Click on the Extrude button again. This time we will add to the part. Click on the sketch on the feature list to turn on its visibility. Click on Add to add this to the arm. Select the regions for the arm. The direction should be in toward the valve. For the depth, Enter 10 millimeters. Make sure the merge scope is for the new part. This looks right. Use the green check to close. Now looking back at the drawing, notice that there is a hole through the arm. The purpose of the hole is to receive a pin to lock the arm to the stem. This is a 12 millimeters through hole. The hole is centered on the large end of the arm at 20 millimeters. Also note, there is a matching hole in the stem to also receive the pin. We can add this hole to both parts now. To create the hole, we will start with a section view. Click on the camera and render options. Choose section view from the menu. For the cutting plane, choose the right plane from the feature list. Use the sketch button on the toolbar to start a new sketch. Choose the right plane from the feature list for the sketch plane. Use N on the keyboard to view normal. Make sure the origin is visible. Click on it on the feature list if necessary to turn on its visibility. Click on Center Point Circle from the sketch toolbar. Hover on the origin, move left to the actuator end while making sure the horizontal icon stays visible. Click for the center of the hole. Enter 12 millimeters for the diameter. Click on the Dimension tool on the toolbar. Dimension from the center of the circle to the outside edge at 20 millimeters. This looks correct. Use the green check to close. Right-click and turn off section view. Click on the Extrude tool on the feature toolbar. Click on Remove. For the sketch region, click on the last sketch in the feature list. For the end type, choose Through All. Check the box for Symmetric to cut in both directions. In the Merge scope, make sure that both parts are included. This looks correct. Use the green check to close. This looks good. This part is now complete. Right-click on the new part in the parts list. Name this part Arm. Let's also clean up the feature list and create a folder for the arm. Click and select all of the features for the arm on the feature list. Right-click and choose Add Selection to a folder. Name the folder Arm. In this segment, we will create the valve plate. We will start by examining the drawings and identifying the features that share the same specifications as other parts. The plate has an outside diameter of 200 millimeters. This size matches the inside diameter of the body and is set in the variable #ID. When the inside diameter changes, we want the diameter of the plate to also update to match. There are 3 9mm holes that are clearance holes for the M8 screws. These are centered on the plate and match the threaded holes on the stem. The plate has a thickness of 5 millimeters. To create the plate, we will start with a section view. Click on the camera and render options and choose section view from the menu. Choose the top view in the feature list for the cutting plane. Click on the sketch button on the toolbar. Use the top plane in the feature list for the sketch. Use N on the keyboard to view normal to the sketch plane. Click on the Use tool on the toolbar. Click on the inside edge of the body to use for the outside edge of the plate. Click on Center Point Circle on the toolbar. Hover on a hole on the stem and click Concentric for the center. Create a slightly larger hole. Enter 9 millimeters for the diameter. Create additional concentric circles at each of the remaining screw holes on the stem. To set all of the holes equal, click on all 3 holes. On the constraint menu, click on Equal. This looks right. Use the green check to close. Click on Extrude on the feature toolbar. This will be a new part. For the sketch, click on the sketch in the feature list. The end type is blind. The direction is up. The depth is 5 millimeters. Right-click and turn off the section view. This looks right. Use the green check to close. Right-click on the part in the parts list. Rename to plate. On the feature list, put the features for the plate in a folder. Name it Plate. This completes the final part for our valve mechanism. Before we start the assembly, let's check that our model will behave as expected when we change the variables. Let's start with a right side section view. Click on the button for the variable table on the right. Change the inside diameter to 250 millimeters. I can see that all of the parts update and there are no errors in the feature list. Change the height to 300 millimeters. Again, this looks good. We can now proceed to making the assembly. In this segment, we will assemble the butterfly valve and use animation to view its operation. In the document, you should have an empty Assembly Studio tab on the bottom tab bar. If you don't have one, click on the plus in the lower right corner and choose Create Assembly. In the assembly, click on the Insert button on the toolbar. For the current document, there is the one part studio that contains all of our parts. The body will be our base part, so click to select it. Use the green check to close. Right-click on the body and choose Fix from the pop-up menu. Notice on the instance list, the body is now marked with a Fix icon and the part will not move in the assembly window. Next, we will insert the stem and the plate. We will use a Fasten Mate to attach the plate to the stem. Click on the Fasten Mate on the Assembly toolbar. Click on the mate at the top of the center screw hole on the stem. Hover of the center hole in the plate, click on the mate at the bottom of the hole. This looks good. Use the green check to close. The stem needs to rotate in the body, so we will use a revolute mate to assemble the stem in the body. Click on the revolute mate on the assembly toolbar. Click on the mate connector on the inside edge of the shoulder on the body. Click on the mate connector for the inside shoulder of the stem. Use the Solve button to reapply previous mates. Next, we will insert the retainer plate. For this part, use a Fasten Mate. Click on the mate connector at the center of the top screw hole on the boss. Click on the mate connector at the bottom of the same hole on the retainer plate. This looks good. Use the green check to close. Now we can place the actuator arm. This will also use a Fasten Mate and it will turn with the stem. Choose the mate connector on the center of the face of the stem. Choose the mate connector at the center of the outer hole on the arm. This looks right. Use the green check to close. We have now placed and mated all of the parts that we created in the Part Studio. Next, we will place fasteners from the standard content. We will start with the screws that fasten the valve plate to the stem. Looking back at the drawings, the specifications list these as panhead screws, M8 by 1.25 with a length of 25 millimeters. In the assembly, click on Insert. Choose Standard Content from the type to insert. For the standard, choose ISO. For the category, choose Bolts and Screws. For the class, choose Cross Recess Head Screws. For the component, choose PH Pan Head Screw. The size is M8. The length is 25 millimeters. The thread length is 25. They are steel. On the instance list, turn off the visibility of the body. On the plate, click on each of the holes to select them. Click on the Insert button in the dialog box. Screws should be inserted into each of the holes with the mate connector visible. This looks good. Use the green check to close. Use Shift and P on the keyboard to turn off the visibility of the mate connectors. Turn back on the visibility of the body. Now we will place the bolts that secure the retainer plate to the body. Again, looking at the drawings, these are hex head screws, grade C. M12 by 1.75 with a length of 45 millimeters. Each bolt is paired with a chamfered plane washer sized M12. In the assembly, click on Insert. Choose Standard Content from the type to insert. For the standard, choose ISO. For the category, choose Bolts and Screws. For the class, choose Hex Head Bolts and Screws. For the component, Hex Head Screw Grade C. The size is M12. The length is 45 millimeters. They are steel. On the instance list, turn off the visibility of the arm. On the plate, click on each of the holes to select them. Click on the Insert button in the dialog box. Bolts should be inserted into each of the holes with the mate connector visible. This looks good. Use the green check to close. Next, we will insert the washers. Click on the Insert button in the dialog box. This time the category is Washers. For the class, Plain Washers. For the component, Chamfered Plain Washers. The size is M12. The material is steel. The finish is plain. To choose the holes for the washers, click on the face of the retainer plate and Onshape will find all the instances. Click on the button for Insert closest to selection. This should insert the washers on the plate and under the bolt heads. This looks good. Use the green check to close. Use Shift and P on the keyboard to turn off the visibility of the mate connectors. The last component in the assembly is the pin that locks the actuator arm to the stem. Click on Insert. Again, we are using standard content. This time the category is Pins. The class is Parallel Pins. The size is M12. The length is 100 millimeters. The material is steel. The finish is plain. Click on the Insert button and place the pin into the assembly window. Use the green check to close. Click on the Fasten Mate on the assembly toolbar. Click on a mate connector at the bottom of the pin. Click on a mate connector on the hole on the outside of the actuator arm. This looks good. Use the green check to close. Now, let's check the assembly by taking a look inside using a section view. Click on the right side of the view cube to view normal. From the Camera and Render menu, choose Section View. Click on the body and view the half section of the assembly. I can see that all the components have been placed correctly and the fasteners fit accurately. Right-click and turn off Section View. The assembly is complete. Now we can view the action of the butterfly valve by applying an animation. On the Mate Features list on the right, locate the Revolute mate used to mate the stem. Right-click on the Revolute mate and choose Animate from the menu. In the dialog box, click on the play button and the valve should rotate on a 360-degree rotation. In actual operation, the valve would only turn 90 degrees for a full cycle. Set the start at 0 and the end at 90 degrees. Press play to view. This looks good. End the animation. Congratulations on completing this project. The last step in this project is to check if our design intent was successfully applied. We started by identifying 2 parameters that we want to be able to change and have all of the parts respond by updating without causing errors. In the Part Studio, click on the button to open the variable table on the right. Change the value for the inside diameter from 200 to 225 millimeters. The part should update in the Studio window. Now change the value for the height from 250 to 275. Again, the part should update. Check the feature list for errors. This looks good. Click on the Assembly tab. The assembly model should also be updated. There are no errors in the instances or mate features. Click on the Measure tool in the lower right corner. Click on the inside hole of the valve body. This should measure 225 millimeters. Use the spacebar to clear the selection. Click on the body of the valve. The height should read 275 millimeters. This looks good. Our design intent has been applied correctly. Thank you for watching. If you enjoyed this video, look for more projects at cadvideotutor.com. Also, hit the like or subscribe button. If you have a question, leave a comment.